Alright, today we're going to be looking at a special type of factoring, which is the factoring the difference of two squares. So a square would be something, so if you think about x plus y, x minus y, and you think about how this distributes, you would multiply the x to both of these. X times x is x squared. X times negative y is negative xy. And then you would multiply the y to both of these. Y times x would be xy, and y times negative y would be negative y squared. But if you look, these positive xy and minus xy would cancel. You'd be left with x squared minus y squared. So this special form, x plus y, x minus y, factors to x squared minus y squared. And this would be true even if we had numbers for x and y. It turns out that something is in this form where it's a difference of two square numbers, then we can take the square root of these to figure out what our two factors are. Our first factor would be x plus y, where x is the square root of the first term and y is the square root of the second term. And then we have x minus y, where x is the square root of the first term and y is the square root of the second term. The steps here, the same as usual, write in standard form. If the first term is not positive, you need to factor out a negative. If the GCF isn't 1, you need to factor it out. Well, let's look at some that have this pattern, the difference of two squares. So, x squared minus y squared factors to x plus y, x minus y. Alright, the easiest way to do this is to write each one as a square. So we have blank squared minus blank squared. Alright, well, the first term is obvious. What do we need to square to get x? Well, we need to square x. X to the second power is x. Minus, and what do we need to square to get 4? We need to square 2 to get 4. So 2 to the second power is 4. So what this tells us is that this is a difference of two squares, x squared and 2 squared, x squared minus 2 squared, which means we can factor it into this special form, where the square root of the first number, where what's in this parentheses plus this, and then what's in this parentheses minus this. So this factors into the special form x plus 2, x minus 2, and that would be our factored form. Let's try number 2. We need to set it up the same way. We have two terms subtracting, so it's a good chance that this is a difference of two terms, or difference of two squares. So we have the first square minus the second square. We need to figure out what's in the first square. So we have a number and we have a variable. Well, we know x to the second power is x squared. What to the second power is 16? Well, 4 to the second power is 16. So 4x to the second power is 16x squared. And then what to the second power is 1? Well, 1 to the second power is 1. So now I see this is indeed a difference of two squares. So in this case, I would do this plus this for the first factor, and then this minus this for the second factor, 4x minus 1. Alright, what about number 3? There's two terms, so and they're being subtracted, minus, so let's check to see if this is a difference of two squares. So we know this right here, x to the second power is x squared, that one's fine. But what do we raise to the second power to get 1 over 25? Well, we need to separate this into numerator and denominator. So 1, what do we raise 1 to get 1? We raise 1 to the, what do we raise to the second power to get 1? We raise 1 to the second power because 1 squared is 1. And what about the denominator? 25. What's the square root of 25? It's 5. Same thing for the second part. Square root of 4 is 2, and the square root of 9 is 3. So that's 2/3. So 1/5 x squared minus 2/3 squared. So this is a difference of 2 squares. Now we can factor it into the special form where the first factor is this plus this. So 1/5 x plus 2/3. And the second factor is this minus this. 1/5 x minus 2/3. So that would be our factors for number 3. Number 4, x squared plus 16. Well, this one has 2 terms, but it's not a difference, it's a sum. And we're looking for a difference. It has to have subtraction between them. So this is not factorable, at least not in the way we're trying to do it. So this is not factorable. All right, number 5. Well, this one has a GCF. All of these had a GCF of 1. So number 1 had a GCF of 1. Number 2 had a GCF of 1. This one had a GCF of 1. However, number 5 has a GCF of -1. So before we begin, we need to factor out that -1. So -1 comes to the outside. We're left with x squared minus 81. Well, now we want to factor x squared minus 81. It has 2 terms and subtraction between them, so let's check to see if it's a difference of 2 squares. So the square root of x squared is x, and the square root of 81 is 9. So it is a it is a difference of 2 squares. So this is going to factor into x plus 9, this plus this for the first factor, and then x minus 9, this minus this for the second factor. However, don't forget the -1. -1 is also a factor. So we do need to include the -1. So we'd have -1, x plus 9, x minus 9. Those are the 2 factors of x squared minus 81. Number 6, well, first of all, we need to put it in standard form. Alright, it is not in standard form. The -9x squared needs to come first, and the 81 comes next. Now we need to take out the GCF. The GCF is -9. So we have -9 x minus 9. Sorry, x squared. Alright, well, can x squared minus 9 be written as a difference of 2 squares? Sure it can. Let's just take the square root of each term. The square root of x squared is x, and the square root of 9 is 3, so it can be written as a difference of 2 squares. So that means this plus this is the first factor, and this minus this is the second factor. Don't forget about -9. -9 was also one of the factors. So this would be my factored form. -9, x plus 3, x minus 3. And let's look at x squared minus 50. Let's write it as a difference of 2 squares. So that's going to be taking the square root. The square root of x squared is x. Whoopsie. Square root of x squared is x. And the square root of 50 is just the square root of 50. Okay, we don't actually, if you put that into a calculator, it's not going to give you anything that you can use. It's going to get like 7 point something. So we're just going to leave it as square root of 50. So the first factor is this plus this, x plus the square root of 50. And the second factor is this minus this, x minus the square root of 50. And it's going to be that pattern every single time. It'll be that same pattern every time. Alright, so you're going to want to finish the rest of those problems on that sheet, numbers 11 through 20. Check your answer using the distributive property, make sure that it is correct.